Okay, good afternoon and welcome back, makers. We are hoping that everyone is doing well and healthy during social distancing, practicing washing your hands, and always staying safe. So, here we are again for the introduction to Microbit Start Kit Volume 2. Okay, here we are going to learn the very basics of programming and computer science with the experts. And we can get creative with the latest digital technologies and where we can code, customize and control our microbit from anywhere that fits in most in our digital creations. So as for today, we have Mr. Vincent from Rero Edu team to teach us how to create amazing creations from Microbit Quick Start Kit. So let's get excited and I shall hand over this time to Mr. Vincent Go.
Thank you so much, Karen. All right. I'm not there to calling myself expert, but we are just here to share what we have learned. Okay. For this microbit, like previously we had shared on like how do we do the hello world, like show the word source string in this LED matrix, 25 matrix. So later on we will do something with light, and then how are we going to program a melody to use the piezo buzzers to create melody by using this board. Okay, so I want you all to go to okay. So before we start, let us watch something like, okay, just to recap. So we need to go to this website, http://maccord.microbit.org. But if you are with me now, probably we can do something like, go to this classroom, okay? I will share the classroom to you. Okay, you can use, if you are with me at this moment, you can join this classroom, okay? So it's similar to the Maccord editor page, but this one I can be able to see your code, all right? So I will be able to see my student code here, and then I can like guide you straight away from here. So what you need to do is just to go to this website, microbit.org/join. Then you key in this classroom name and the PIN number, and then we can start to our lesson of today to create the piezo buzzer, to put down some music using the microbit, and then how we're going to connect it. Okay, so I'll just give you a moment. You can use your handphone to screenshot, and then to be able to like join this classroom. Okay, I'm going to move quite fast a bit, so you just need to screenshot this and then join the class if you're with me at this moment. If not, then you can always go to this. Okay. Okay, I will go back to my slide. Then you can just go to this. Okay. Okay, so maccord.microbit.org. Okay, this is normally if you don't have a live stream, then you can go to this website to do your coding. Okay, so just a quick one. So in this one, you can actually do like broad programming and then JavaScript. Okay, so these are the work plan. Okay, so that this one you will know that like what other coding that you program, you will put it here inside. All right. Okay, this one don't need. Okay, so microbit have two buttons. Later on, we will try to program up to your preference. You can do like on button A press or on button B press, or you can do both button press, then do the action that you want. Okay.
You've probably seen.
Okay. Okay, we won't do the bread rock, paper, scissors, but we are doing music. Okay, today we are doing music first. Okay.
Sweet. Time to test these new speakers with some jams.
Okay.
Looks like I won't be able to blast my music after all. But there is a way I can listen to music without interrupting others. Headphones are just small speakers that sit outside or inside of our ears. We can use them to listen to music, audiobooks, and podcasts. Interestingly enough, we can create simple music using our microbit, and we can play these sounds through a speaker, or if we don't want to disturb anybody, through some headphones. But first, let's look at how speakers work. We start with a permanent magnet that's in a tube or donut shape. We have one side that's north and the other that's south. We put a coil of wire around another tube or rod. Together, this coil and rod are known as a voice coil, and they move independently in and out of the magnet's hole. When we put an electric current through the wires on the voice coil, we create an electromagnet. One side will be north and the other will be south, just like our permanent magnet. And like permanent magnets, opposite poles will attract, which means the voice coil will move toward the magnet. If we switch the direction of the electric current, the poles on the electromagnet will swap. Now, we have the same poles facing each other, so the voice coil will be repelled away from the permanent magnet. To use this motion to create sound, we add a cone of paper, wood, plastic, metal, or some other material to create a sort of diaphragm. As we switch the electric current back and forth, the voice coil moves in and out of the permanent magnet, which moves the diaphragm. This rapid back and forth motion creates pressure waves in the air, and we call these pressure waves sound. You can see the individual parts clearly on this small speaker. The permanent magnet is visible on the outside of the voice coil, sitting underneath the clear plastic diaphragm. The upper lip of the diaphragm is held to the metal casing by a flexible suspension material. The voice coil is held in place by a ring of flexible material known as a spider, which allows the voice coil to move just up and down. If I switch the electric current back and forth through the speaker really fast, like 20 times per second, you can see the speaker diaphragm vibrate. However, you can't really hear 20 hertz. Now, if you change this to 440 hertz, the note A4, you can hear it. The problem we run into with most speakers is that it takes a lot of force to move the diaphragm back and forth. Well, relatively a lot of force. I can move it easily with my hand, but it takes a lot of electricity to make the electromagnet strong enough to move it. In order to produce the electricity necessary to drive speakers like this, we need a special piece of hardware known as an amplifier. An amplifier takes an electric signal, say your favorite song, and then increases the amount of current going out to other devices, like speakers. Some amplifiers can be small, like this simple board, and they're good for driving small speakers like my clear plastic one. Some amplifiers can be big, like the one built into the stereo receiver. These are capable of powering large home theater sound systems with multiple speakers. These shelf speakers have built-in amplifiers, but even if you don't have an amplifier available to you, you can still power very small speakers with the microbit, like the ones found in headphones. If you pull apart the casing on most headphones, you'll find a small speaker for each ear. Let's use this to play a song. To get music from your microbit, connect an alligator wire to the ground pin. We'll use black. And connect another to pin 0, white in this case. Connect the black wire, the one attached to ground, to the lowest ring on the headphone plug. Then connect the white wire, the one attached to pin 0, to the tip of the headphone plug. This will send our electric signal to the left speaker of our headphones. In MakeCode, go to Logic and drag an if-else block to forever. Click the plus button on the if-else block to get an else-if condition to appear. From Input, drag button A is pressed block to the if condition. Drag another to the else if condition. Change the second one to button B. From Music, drag a ringtone hertz underneath if and drag a second one to underneath else if. If you click on the tone, you should see a keyboard pop up. We'll use it to change which note is played. Change the button A note to middle E and change the button B note to middle G. We want the notes to stop playing whenever we release the buttons. Click on Advanced and open Pins. Drag a digital write pin block to underneath Else. We'll want pin P0 to be set to 0 when no buttons are pressed. Download and copy this program to your microbit. You now have a super simple instrument. Press the A and B buttons to play some kind of two-note song. Please be careful. The sounds from the microbit can be quite loud. Test the notes first before putting the headphones in or next to your ears. You can play various notes and tunes on your microbit using small speakers and headphones. If you have an amplifier available, you can really crank that volume up to high levels. Just be sure not to annoy your neighbors. Besides, that will only lead to treble.
Okay, so that's how you are going to connect your piezo buzzers. If you don't have the hardware, no need to worry, because from the MATCode editor itself, it has a simulator for you to play with your program, okay? All right, I'm going to share this. So this is going to, okay. Maybe I just show the slide. Okay, for you to do the program, you can do this one. Okay. So you can try to like play any music tone by just simply use on button B press or A, up to you. You can just play just now the video, it shows you the two tone. Okay, so A is what tone and B is what tone, and use the if else logic. But then for this lesson, I'm going to try some music. Okay, so that it's easier for you all to follow. Okay, so before I go into that, okay, let us try to read the notes. Okay, for the whole notes, there are 4 bits, right? These are the sign here. This is a whole note, so it will be a duration of 4 bits. Okay, so this horizontal line here, there are 5 staff, we call it staff. Okay, so the higher the pitch or frequency of the sound is depend on note sit on which of the staff. Okay, okay, so on this one, the whole note is 4 bit, right? And this one is like the white color, and it's like something like a tauge. Okay, so this is 2 bit. Okay, if it's a black color, then it's 1 bit. If it's black color and 1 tail, then it's half a bit. So if it's like black color and then got 2 tail, then that is a quarter of bit. Okay, quarter of a bit. Okay, so now let's try to program this. Not sure you'll be able to see. Okay, so but never mind. I can do. Let's see what I can do for you here. All right. I'm going to share this here. Sorry. Okay, you should be able to see. Okay, on button A press. Okay, you can just follow me. Then you can create this music. So the first tone here is middle C, and then a half a beat. Then you can Control C if you're using Windows, and Control V to copy and paste. And then when you click here, you can choose like, let's say you want middle D. Okay, So this is meter D, and then you want it half a beat. Okay, so just continue to select the tone that you want. Okay, so now, if you want a quarter beat, how do you do that? You can do this, okay? Okay, or you can actually use the equations. Okay. You can use the map equation here. Let's say you want 2.5 beat. Okay. So this is 2.5 beat. Okay, this is how we're going to do if you want like 2.5 beat. You can play around with the map equations, okay? Then you rest half a beat. How are you going to do that? Okay. Go and find this rest. Then put it here. Okay, you can copy this one. And you can just drag, and then when there is a 2 dot connect line together, then you know that they are be able to go inside the box. Okay, this is 1.5 beat. So just now I just press a Control C is copy, okay? This is just like the Microsoft Word. Control C, copy, Control V is paste, okay? Then rest for half a bit again. You can control from here. Oh, this is half a bit. This is also half a bit. Half a bit. High C to B. And then rest half a bit. Okay, let's say if you cannot find the rest, can try to type here, search your rest, type rest, then you can be able to see this block that you want. Okay, you can just drag and then you can drop here, okay? Or you can just go and find previously if you used it before, then you just select the block and then Control C, then Control V, press it there, all right? Okay, now C, high C. This one. ID. And then again. So I need 2 more. Okay. Oh, half a bit. Then high C, half a bit. Middle. Then rest for 2 bit. Oh, rest for half a bit. Okay, copy and paste. high C for half a beat. Middle A. One beat. Middle G for one beat also.
It's 15 hours.
Middle A. One beat. Middle G for half a beat. Equation. Press. Okay, you can actually zoom out. Okay, if the code is too long, and then after you can just zoom right back in by clicking this button, or you can use your mouse to scroll it. Then you rest one beat. Okay, so now you can download it to your micro:bit. Click download. If you don't have the micro:bit, doesn't matter. Okay, you can use the simulator to just to see the music tone that you just coding just now. Okay, so after I pair the device, when I ever click download, I don't need to copy and paste the hex file. So if you have your PC, because some browser doesn't support pair device, so you need to like download and then you copy the hex file and then you transfer the file to your micro:bit. Okay, but since I have the pair function available, so I will just use the, after I pay, then I will download it here. This is a micro:bit. So whenever it's downloading, then it will be fresh. Okay, after it's complete, then you will stop freshing. That's why we call this fresh. Okay, to fresh the hex file inside in the micro:bit. All right. Okay. Just for you to see, I have connect the my visualizer is unable to working today, so I have to use the webcam to show you. Okay, so I have connect this to I use the product create. Okay, so one I connect to pin 0, right? So pin 0 go to positive. The negative is ground. Okay, so after you connect this, then you can be able to play the music that you have just coded just now. Okay, just I select press button A. So can you hear? So this is the music that you have just coded just now. So to connect it, okay, green color, no, black color is ground. So you connect to your negative. negative is the shorter leg, all right? No, this is not LED. So if LED, then shorter leg. So this one is like red is the ground. The red color is the positive, okay? All right, so if you don't have the micro:bit, the hardware, you can always use the simulator. You can just press this one. Then your laptop will tell you to generate your recording, and then the simulator will play the music if you're using the. All right, so this is how you do the simple. To you can use your headphone if you want to program some melody using your micro:bit, the project. Okay, usually if you have this expansion board, okay, so you can come with okay, this is you don't need to do all the Crocodile Crate and also able to do the wiring, but then you just need to download to the micro:bit here. Okay. Okay. So this one you don't need to do all the wiring. Okay. Because inside the expansion board come built in with a piezo buzzer. Okay. So whenever that you download it, right, you will be able to play the music for you through the expansion board. Okay. For Quick Start Kit doesn't come with all these luxury, but then you can always DIY like a music box by using the Crocodile Crate, but just a bit more of cable management. I think you should be fine, right? So this one is still flashing, so it's still downloading the code. Okay, after it does, right, then it will stop flashing. Okay, then you can play the music. Okay, let's try. The music is louder, right? So same thing. We'll play the music also powered by this 1X650 battery, lithium battery. But for this one, you have to use the power pad that is available in your kit. All right. So after you download, right, then you can use your power pad, the battery power pad. This is the battery power pad. So you connect to the pin. Okay. The power pad need to connect to this pin. Okay. Then you will be able to unplug it from your PC. Okay, unplug it from your PC to play the melody. Because for just now, I'm using the laptop power to power up the micro:bit to be able to play the music. Okay. Now, let's try to do this. Okay, this the baby shark. All right. So you see the knot here, the BY here. So this is how many bit? So this is all 1 bit. Okay. And then the do, then you try to, if you have time, you can just freeze this and try to program this, and I'll download it to your micro:bit to do this baby shark show. I'm not going to do that because it will take too much time. So I will move on to next lesson in a bit. All right. Now, here you have the LED. So in the first volume, we have tried to power up the heartbeat by using the red LED. Then it will beat according to the heartbeat. Okay. Then the red LED will light up according to your habit. So now we are trying to do something with three LED to do a traffic light, or you can do a chasing light. Okay, so you need a 3 resistor here. Okay, you can use the 2 connector board, which is inside the box, and then you can connect it to 3 resistor. So you can connect by using the negative to connect to the connector board, the shorter leg. Then after that, and again, so here you have pin 0, pin 1, and pin 2. So here you can try to do the traffic light program. If you want to do more, right, then you have to use expansion board. Okay, because we don't have because the aggregator clip is the crocodile clip is very big. So whenever you click on it, right, then you wouldn't be able to, if you want to take out like pin 2, pin 3, you won't be able to choose the pin 3 because the aggregator tip is just not so accurate already, because when you click here, these are the smaller pin area here. So you won't be able to connect it precisely. So what you need to do is you need to get the expansion board if you want to do more than 3 LED. Okay, for this, we are going to do just 3 LED. How are we going to do that? Let's see. Okay, we can clear this out. I can share the code to you if you're inside the classroom. If you are not, then you have to program it, follow the video at a later time. Okay. So now here. Okay, let me share the screen for you. Okay, share. Okay, we'll share these. Okay, I hope we are on the right. Okay, okay. So this one, you can go to advanced. Here you can select the pin. Okay, digital right pin. Okay, so digital right pin is like I mentioned before, 0 is off and 1 is on. If you want to on it, then put 1. There are only 2 values lah. Okay, basically 0 or 1. This is the digital pin. Okay. Now after that, you want it to like how many seconds you want it? You can use the mouse Pro. Okay, let's put 1 second. Then after that, copy and paste again. P1. Okay. Then also 1 second. P2. So this is just very simple coding, okay? So how do you see from the simulator? Okay. Here I can't be able to see, maybe I'm using the classroom microbit. But if you are using this, let's see. Okay. Let's see, we'll be able to see the maybe because I need to use the LED. But this LED is the matrix one, so yeah. Okay, so that's why it doesn't show in simulator. Okay, maybe yeah, because I'm using the pin to write the signal to just to on it. So maybe it doesn't, you can't be able to see from simulator in this case. Okay, never mind. And I will just through, okay, this all three here is negative. So negative is connect to the ground. So I'm going to connect it to the ground. Sorry, yeah, for those that doesn't have the hardware, you won't be able to see from the simulator in this case. But what I can show you is to how are you going to do the wiring connection. So all these three can use a Kurotal grid to create all three here. Okay. Okay, this is ground. So you create all three here. Okay, then this one you connect to the ground. Again, I apologize because my visual presenter cannot connect to my virtual machine, so I cannot share the video to you. But this is how you connect to the ground. And then the pin 120, you have to use the three different, let's see. Okay, I got three, got click, so just need to connect you. Okay, let's try. Okay, now just need to download. Okay. So now all the LED will be able to light out. So now let's try. Clear out the program. So off it. Okay. Let's see what it does. My red color doesn't light up. Let me check the polarity. Okay, let me change the. Oh, okay, no wonder I did not connect. Sorry. Okay, let's try. Okay, not sure you can see or not. So your light out like. Okay. Yeah, something like this. Okay, so maybe the power is not like consistent, so you need to probably use like I would suggest you to try to using the expansion board, but then okay, I also like doing this like using the breadboard. If you have the breadboard, I think that is better way. Okay, so you use the male-to-male jumper instead of using the connector board. Maybe you can try to get the breadboard to do that. Okay, now we're just going to use the breadboard. See how it does. See if it's better. It's better. So you can use breadboard to show like the better. Okay, so it's better. Okay, so if you have breadboard, then you can connect this way. Okay, so this is how you do the connection by using the jumper wire. Jumper wire is not in the kit, so you can always go get the 40-way jumper wire, male to male, like this. Okay, so this is like 40, I think costs less than 5 ringgit. So you can get from electrical shop, or you can go to Saichong website and get one of these. All right. So yeah, this is how you do the LED light. Okay. So just now, you put 0 here, so it will off it. So that's why you can change the transition. You can see the transitions better. Okay. So if you do not put the 0 here, then there might be some electric currents. So you will still see like maybe all 3 lights lighting up. So to do it better, you can do like this. All right. Okay, now we can try to play a game. Okay. By using the shed. Okay. Let's try. Where are the share? Okay, I'll share this to you. Okay. So for you to code first, you choose the on share. Okay, on share broad. Then from there, you can set hand to pick random 1 to 3. Right? Maybe I just share my editor bro. Okay. Let's try this one. Okay. So I share this instead. Okay, hope you'll be able to see. Okay. So, all right, you can go to input to find the shed. Okay, if you cannot find, you can type shed. So just drag and drop here. So need to choose the variable hand. Hand, rock, paper, scissors using hand, right? Okay, so one you have the variable already, right? Okay, then you can use the random number. Let's try this 1, 2, 2. So 0, 1, and 2. Okay. Okay, after that, we use the if logic. If hand, we need to use the comparison block. Then you choose hand. So if hand is equal to 0, then it will show This is paper. Okay, up to you lah. Whatever that represent the paper, then you just draw the LED, no? Okay, then you click on the one. You copy this one. Raw. Inverted. I try to do the inverted of the paper. That is raw. Okay, then everything else is the scissor. Scissor, something like this lah. Is it like scissor for you? Not sure, but I hope it like scissor to you. Something like this, maybe. Okay, now you can download it. So whenever you share it, try again. Okay. Yeah. Okay. So this is how you play the game, the rock, paper, scissors with your friend. Okay, by using Microbit. So when you play, so you pick random number 0 to 2. So 0 is one number. If it's 0, then you become a paper. If 1, then it will become rock. So if it's 2, then it's the scissor. So these are the simple game that you can play using the Microbit. Okay, all right. So I think time is up. I hope you all learned something today. Then Karen, maybe you want to, yeah. Okay.
Yes, Vincent, Mr. Vincent.
Yes. So I believe the time is up already. So this is like some simple game that they can play with their friend in the class. So to make the coding learning process more fun, then they can create a different project that they like using the Microbit Quick Start Kit. Yeah, but if they want to create more complicated project, they can get the expansion board. So yeah, I think the time is up already. So I pass the time to you.
Okay, thank you very much, Mr. Vincent. So thank you, Mr. Vincent, for sharing such a very new approach and very interesting things on regarding how to create all these amazing creations using Microbit Quick Start Kit. And personally, it looks very, very interesting. I think it's a very good some new things that we can explore. It is very new and also quite simple actually. Once you start from the basics and once you explore more and more, there's so much things that you can do using Microbit Quick Start Kit. So thank you very much, Mr. Vincent. So there you have it. We hope that you guys learn many new things from today's program. So Stay tuned for more programs from us at Makerspace. So see you soon and stay safe.
Thank you, Karen.
Thank
Thanks,
you.
everyone.
Then, are we done?